at a differential equation here, and our job is to find the general solution of the differential equation. Y prime divided by x equals to this y times the hyperbolic sine of x. Hyperbolic sine of x. Okay? There's two main techniques that you learn in a Calc 2 class to solve a differential equation. A first order differential equation is either separable or it's linear. How do you decide between the two? You want to isolate the y prime term. You can call it dy dx or just y prime. Get it by itself. Multiply everything by x here, and you'll accomplish that. When it's in this situation, and the right-hand side can be written as a function of x only times a function of y only, these two single variable functions, the product of them, then you know it's separable. You could physically separate the variables. You could put the y's and dy's on one side and the x's and dx's on the other side. Let's do it. We'll have 1 over y dy by dividing both sides by y, and multiply both sides by dx. We'll have x times the hyperbolic sine of x dx. After you separate, you integrate. How are you going to integrate that right-hand side? It's a product. X times the hyperbolic sine. Not always, but most of the time, when you have a product, you want to take the antiderivative, you're going to have to use integration by parts. Well, you got to pick one part to be u, the other part has to be dv. The u part needs to be easier to integrate, easier to take the derivative of, and when you take the derivative, it needs to be simpler. So let's let that be x. X's derivative is 1. The other part you need to be able to integrate, dv, and yes, the antiderivative of hyperbolic sine is just hyperbolic cosine. You don't have to worry about negatives or anything like that with the hyperbolics. Derivative of u is just dx, 1 times dx. Hyperbolic cosine is the integral of dv, the integral of hyperbolic sine. Remember the formula for integration by parts, uv minus the integral of v du. The product of u and v just get left over. You just paste those two guys together. So that's going to be x times hyperbolic cosine of x. Then the new integral that we're trading in for is just going to be hyperbolic cosine of x. What function has hyperbolic cosine of x as its derivative? Hyperbolic sine of x. And negative is going to come down from the integration by parts formula. You did it. You have the antiderivative of the right-hand side. What about the antiderivative of the left-hand side? What function has 1 over y as its derivative? You got it. Natural log of y. Now, technically, both sides have a plus c, but we're just combining them on the right-hand side here. We're almost done. When you're getting a solution to a differential equation, you want to have y equals. What's the formula for the function y that solves that equation? And so that's our job now, solve for y. How are we going to do that? Y is inside of a natural log. How do you undo that? The inverse function to that is e. How does it cancel? E to the natural log cancels. So you're going to have to take both sides, the left-hand side and the right-hand side, and make them exponents on e, allowing you to cancel and have y. And on the right-hand side, what you have is e to the entire right-hand side. When it comes to the plus c part, you can break that and make it e to the c, which is just another random constant. E to a random constant, just another random constant. You could call it c if you want, but just to notice that just to recognize that it's a changed value, we'll call it capital A, and we're done. You take the derivative of this function and you divide it by x, you get the same thing as taking this function and multiplying it by hyperbolic sine of x. Whew. You did it. Great job. Thanks for watching. My name is Nakia Rimmer. You can get me at CalcCoach.com. Like and subscribe, comment down below, follow, all that. Thank you.